What's up guys, and welcome to this video. We are going to continue with the 2018 November exam, the physics exam, and we're going into question 2. Okay, so let's get straight into it. Okay, so it says a toy car is pushed in a northerly direction along the ground for several seconds and then released. The car continues to move until friction brings it to rest. The velocity time graph is shown below. Okay, so we know that it's going in the northerly direction, so we can say that the positive direction is the northerly direction. Okay, so if we want to try understand what this graph is actually telling us, okay, so here it starts at 0, 0, so it's not moving. Then when we're pushing it, it's accelerating. Then here is the point where we let go, or we remove force. Okay, once we remove the force, the only force acting during this later stage, it's now decelerating. It's still going in the northerly direction, but it's now slowing down, and the only force here is friction. Okay, cool stuff. Now let's get into the question. Okay, so it says the total distance traveled by the toy car in 17.5 seconds is 29.8 meters. Define velocity. Okay, so we have a definition, a nice 2 easy marks. Let's just put it down anyway. 2.1.1 velocity is the rate of change of position. Okay, so that's our definition, and we get ourselves 2 marks. Then it says calculate the magnitude of the maximum velocity of the car. Okay, so we've been given the velocity time graph, right? So what we want to figure out is what the maximum velocity here, Vmax, is going to be. Okay, so we're looking for this point right here. But we've also been given the total distance covered. Okay, so that means the area 1 plus area 2 must be equal to 29.8. So we can say the sum of the areas is equal to 29.8 meters. Okay, so we have area 1 plus area 2 is equal to 29.8 meters. Okay, so what is area 1? It's going to be half times the base of 3.5, half base times height, which is V, plus the next triangle is half. The base is going to be 17.5 minus 3.5 times the height, perpendicular height is V again, is equal to 29.8. Okay, now if we look at this, the only unknown is V, so we can solve for V, and the velocity comes out as being 3.41 meters per second. Again, it just wants the magnitude, so we don't really care about the direction. But if we did want the direction, it would be north. Okay, but it doesn't ask for it. And we get ourselves 4 marks, so we can even put that in there. So this velocity is 3.41. Okay, cool stuff. Then it says the car has a mass of 20 kilograms. The only forces acting on the car during the last 14 seconds, so that is this section right here, are weight and friction. Okay, so if we were to draw a quick free body diagram of this car on the last 14 seconds, it's got weight acting down. Obviously, then it's got a normal force, and it's got force friction. Okay, so it says calculate the frictional force. Okay, so what can we do here? Okay, so first of all, we would calculate. Okay, so this is 2.1.3. Okay, so to calculate the frictional force, we can use the fact that F net is equal to MA. And we know that our F net is only consistent, and we're worried about F net in that direction, or we can say that is the northerly direction, is going to be equal to the, okay, so the force friction is acting in the opposite direction, so minus force friction is equal to mass times acceleration. Okay, we know what the mass is. We know the mass is 20. We're looking for the force friction, So we need to figure out the acceleration. Okay, so to get the acceleration, what we can say is that we've been given the velocity time graph, and the acceleration is the gradient. So the gradient, so the acceleration is equal to the gradient, okay, so which is equal to change in y over change in x. Okay, and that is equal to, okay, so we know, let's take this as 0.1 and this is 0.2 essentially. So we're going to go with change in y is going to be 3.41 minus the y coordinate of this is 0 over here, over change in x is going to be 3.5 minus 17,5. Okay, and we get an acceleration of minus 0.24 meters per second squared. Okay, and again this is in the negative direction because we are decelerating essentially. Okay, now we know the acceleration is minus 0.24, so the only unknown is F, so we can solve for the force friction. Force friction is equal to 4.87 newtons, and okay, so it's a force, so we need to give a direction. Okay, so the direction here, we said that that direction is essentially the north direction, and in our free body diagram our force friction is to the south, so the direction is south. Okay, and we get a nice 6 marks. Okay, cool stuff. Now we move on to question 2.2. So in 1997 a high-speed car broke the world's land speed record. The car accelerated uniformly. Okay, quite important. So basically uniformly just says that it's got constant acceleration in 2 stages, which are shown in the table. The car starts from rest. Okay, again, a little bit of a important piece of information. Okay, so let's do question 2.2.1. So it says calculate the average acceleration during stage 1. Okay, so during stage 1, we know that it undergoes uniform acceleration or constant acceleration, so we can use our UVATs. So UVATS. Okay, so our U is our initial velocity, which we know is from rest, so 0. Our final velocity is 44. Given right there. Our acceleration is what we're looking for. Our time is in 4 seconds, and S is also unknown. Okay, so what equation can we use? We can use the equation V equals U plus AT. We know V is 44, U is 0, plus A, and T is 4. Okay, so let's just make that look a little bit better. 44. Okay, the only unknown here is A, so solving for A is equal to 11 meters per second squared. Okay, and that we get 3 marks for. Then it says calculate the total distance traveled by the car in the 12 seconds. Okay, so the total run is 12 seconds. Okay, so let's start off question 2.2.2. Okay, so let's start off. We're going to have to do this in stages because it covers a certain distance in stage 1. So it's going a certain distance stage 1. Then it goes a certain distance in stage 2. So both of this gives us stage 1 plus stage 2 gives us the total distance. The total distance. Okay, cool stuff. So let's work with stage 1. We've already got our UVATs established, so we can use the equation V squared equals U squared plus 2AS. Let's just put here stage 1. Okay, again we know our V is 44 squared is equal to 0 squared plus 2. We've calculated our acceleration as 11 and S. Okay, the only unknown here is S, so we can solve for S. Let's put a subscript S1. S1 or the distance covered in stage 1 is equal to 88 meters. Okay, now let's go on to stage 2. Okay, so for stage 2 we need a new set of UVATs, so let's put them down, UVATS. Okay, so our initial velocity is going to be the final velocity of stage 1, so it's going to be 44. Okay, 44 meters. The final velocity is given as 280. The acceleration is unknown again. The time is going to be our 12 seconds minus 4 seconds. Okay, so that gives us 8 seconds. And S is also an unknown. Okay, so we actually have to go through a process of calculating the acceleration first. So we can use the equation like before as V equals U plus AT. 280 is equal to 44 plus A times T of 8 seconds. The only unknown here is our acceleration. Our acceleration comes out as 29.5 meters per second squared. Okay, and then, so now we know that value. So now we can use this equation once again. So V squared equals U squared plus 2AS. 280 squared equals 44 squared plus 2 times acceleration times S. Only unknown is S. Let's give this a subscript S2. So we can solve S2 as 1,296 meters. Okay, but we want the total distance, so S total is equal to S1 plus S2, which is going to be equal to 1,384 meters. And that is our final answer. Okay, yeah, and we get 6 marks for that. So that is question 2 done. Yeah, and in the next video we will be going over question 3. Okay, thanks for watching, guys.